Alrighty, back to the grind. Took an extra day off after the streak breaker. Probably should figure out how to do that one from OLs. Find minimum in rotated sorted array. Suppose an array of length n sorted in ascending order is rotated between 1 to n times. For example, the arrays nums 0, 1, 2, 4, 5, 6, 7, missing a 3, might become 4, 5, 6, 7, 0, 1, 2 if rotated 4 times, or it becomes the same thing if rotated 7 times. Okay. Notice that rotating an array 1 time results in, okay, that seems, yeah, you're shifting it left, all the elements left, and the first element becomes the last element, right? No, you're shifting it right. Okay, so rotated it right. Sure. Given the sorted array nums of unique elements, return the minimum element of this array. Given the sorted array nums of unique elements, return the minimum element of this array. You must write an algorithm that runs an O of log n times. Suppose an array is sorted in ascending order. And is rotated between 1 and n times. Huh. Must run it in O log n. Okay, so this is kind of like a puzzle type deal. 3, 4, 5, 1, 2. So I'm returning the minimum element. So yes, returning 1, 0, and 11. But it's not really caring about finding minimum. To find minimums, you can always just use the min function. But it's basically you have to write it in O log n time. Elements are 1 to 5,000. No, sorry, the size is 1 to 5,000. And the elements are negative 5,000 to 5,000. Huh. I don't think I've seen something like this, or I maybe would have remembered something like this. So you have to leverage the fact that it's initially sorted. Leverage the fact it's initially sorted. The rotation itself is going to be 1. That would be nice if it was O of 1. Array sorted nums of unique elements return the minimum element. Okay, let's do, let's say it's 0, 1, 2, 3, 4, 5, 6, 7. So how would I guarantee? So I'm trying to find what is this rotation deal? Like, suppose sorted ascending is rotated between 1 and n times. Notice, given the sorted rotated array. Oh, I see. Okay, so the starting. Okay, I think I see. So the starting array is actually rotated. It's not like the operation within the function is. There's a rotation function inside this thing, or you're not supposed to implement it. You're given a rotated array. Okay, let's go and just do I think maybe I chose too many. Let's say it's just 5 elements. I just need to find the correct pattern here. That's the wrong rotation, right? It's rotated the other way around. So this is the 5 possible things that I would get if it's n is. Well, yeah, the order doesn't. Order doesn't particularly matter, or the values don't particularly matter as long as the order is correct. So it could be like 0, 10, 20, 30, 40 or something like that. All values are unique, which would be required if it was originally ascending order. Interesting. All values are originally unique. Shouldn't be this hard, I don't think. So I think you're just trying to find what are you trying to find here? The only time where is it true? I think it's true that the only time the first element and the last element is such that the first element is smaller than the last element is if the rotation is like equivalently 0, like mod n. Any other time it's going to be not that. So I think I just need to identify like which half of the array has the discrepancy between the first and last parts. So for instance, if this was, let's say I take this thing and this thing, like 401 versus 23, 23 being in the correct order for the first and, like those are the halves of the array. 401 is the first half, 23 is the second half. 23 being in correct order for the first and last element of the half means that the kind of breakage where it's been rotated through is not in that half. So therefore it's in the first half where it's like 40, the break in the rotation. Same thing here, 3 is between 0, so the first half has the break between 4 and 0. This one, 2, 3, 4, and 0, 1. Okay, so that one means that if there's no break, if both halves are increasing, then the break point is between the dividers of the halves. Okay. Find the breakpoint where array decreases in order. As array has decreasing values. Array first last elements in that half of the array. I think I could probably do this recursively. Yeah. It's the easiest way. Find break. Guess I'll pass in indices. A and B. And then this probably just return the index or return the value. Alright, so recursive functions always going to start with the base case. So the base case where it doesn't recurse is if is what exactly? If there's no it doesn't decrease or increase. If the person last is an increasing order. Nums at A is less than nums at B. Then the first element is the smallest. So that's the base case. Otherwise, so if it's increasing, I guess I'll just do mid is equal to A plus B divided by 2. Return the min of find break. I don't feel like I'm doing this correct, to be honest. A to mid and find break of mid plus 1 to B. I guess maybe if they're the same, if there's the same index, then it doesn't matter. Or if A less than or equal to B, or A plus 1 equals B. A plus 1 greater than or equal to B. I don't think that's right. What if they're 1 apart? If they're 1 apart, like 3, 4. No, if they're 1 apart and it's like 4, 0. What am I supposed to do there? If it's 4, 0, then this would actually do another recursion. Yeah. Okay, let's see how fast this goes. So it's inclusive of both indices, so it's like length of nums minus 1. this would be find break. Okay, it's misspelled. Okay. There's some slight optimizations I could do here, but it's all fine. Okay, so somewhere here, use recursive function to identify where the break is. Split the array into, or split the indices into 2 halves, and a break can be found within the half where the first and last elements are in wrong order. If in the correct order, i.e. first is less than the last value, then first value is min of that half. So like if I do 401, let's say I actually have 5. So if I do something like this, if I break this into 2 halves, the 1, 2, 3 half, the first value here is 1, the last value is 3, so that half is in the correct order. The minimum value there is just 1. 4, 5, 0, the first value is 4, the last value is 0. It's in the incorrect order, so there's a break in somewhere in this. The break is going to identify where the minimum value is, because the minimum value is going to be right after the break. Min value of the array is value after the break. So keep recursing until the break is found. Base case, non-recursive case of the function call is when array A is less than array B. Then return array A. Well, basically the value of the first index. Complexity is going to be O of log n, since we're doing a variant of binary search, which, is the classical O of log n case. And then space width is O of 1, since no extra space is needed.